in-contact CTO, Ned Borden, on many occasions deliberately repeats uptime is there. It is with a very specific intent that we all nicers understand importance of uptime. Even we nicers emphasize more on a fact that reliability is one feature used by all of our customers. This usually sets the tone of most of our design conversations. I'm sure we all will agree that nothing really matters if you cannot breathe. The same is true with platforms. Even the best features have no value if the service is down. It is a known fact, and you may have experienced it. If there are 10 things which can go wrong, the one thing that goes wrong usually causes maximum damage. If things are meant to go wrong, they will go wrong. Throughout this presentation, let us all hook up to this thought. It will help you understand our urge behind chaos engineering. Today, NICE hosts multiple cloud native suites on a single platform. And because of this, chaos engineering is very crucial for us. If a platform goes down, it has direct impact on business continuity of 3 mission critical domains. At NICE, we contribute towards building SaaS-based platform services for various domains. It includes cloud native suite and softwares for contact center industry, also known as CX1, financial crime detection software for banking, also known as XI, and robotics process automation for back office. We call it as NEVA. NICE primarily focuses on giving a seamless customer experience across the entire customer journey. Under this customer journey, stability is the most important feature that we usually deliver. Now we feel it is an appropriate time to introduce us. Hello folks, I'm Yuvan. As a platform architect, I contribute towards platform services like authentication, authorization, storage, user management, etc. My core responsibility is to assure resiliency considerations under the design, implementation, and support phases. A part of my responsibility is also to build vision for chaos engineering, which effectively helps us in validating our platform stability. With this, I will hand it over to Mehul for his introduction.
Thank you, Yuvraj. And hi, everyone. My name is Mehul Tripathi, and I've been working as a performance engineer for 12 years. Here at NICE, my responsibility, I'm working as a PSR lead for the same platform services that Yuvraj talked about. My responsibility in nutshell is bringing up the right practices in terms of testing and engineering to strengthen the stability of the platform. And chaos being one such practice, the part of my responsibility is to create a roadmap to implement chaos as a practice, as well as getting that implemented across the board. Over to you, Raj.
Thank you, Mehul. As part of the agenda, we'll spend some time in understanding chaos. Then we will see various constraints of chaos engineering. And we will also factor in what are the things required for the readiness of chaos and to act for chaos. From the architectural point of view, we will go through few things which will help you understand how you can save time and money when you factor in design considerations related to chaos. Further, it will be taken up by Mehul, and he will run us through various considerations to implement chaos within an organization. He will help us understand chaos engineering with a chaos experiment. And in the end, we will end it up by sharing benefits and gain that we gain from chaos engineering. I'm going to skip this video, but do make a point to go and watch this. This is a clip from IT Crowd. The character's name is Maurice Moss. In this video, he actually exhibits chaos in various actions he takes towards extinguishing a fire that occurs at office. Now let's understand the simple definition of chaos. Any confusion or disorder that exists under a communication and process is chaos. Chaos usually brings in unknown and complexity with it. When there is unknown and complexity under a system, it inculcates fear and lack of trust in that system. There is unpredictability under the behavior of that system. You will see this unpredictable behavior and unknowns and complexities under various phases of software development lifecycle. When we are under the development phase, lack of requirements, unclarity related to the design usually builds chaos under the development phase. This was majoritarily streamlined by the process which we call as agile. Furthermore, when we deploy our software to production, in the older times, we used to deploy monoliths on a cluster-oriented architecture, and we are well aware about the chaos that existed during those times. On the modern systems, this was furthermore streamlined by using a CI/CD process. The most ignored part, usually under the software development lifecycle and under the lifecycle of any software execution, is the operational phase. Chaos engineering is the practice which actually helps us streamlining these operations. Let's take an example of a fire department to understand chaos engineering and how it is important to follow a practice. As fire department says very crucial guidelines with various premises. As part of the guideline, it requests various premises to install smoke detectors as an identification mechanism. If there is a fire, it recommends to have sprinklers so that we can control fire early. Suppose if there is an outburst of fire, then there has to be a nearby water resource, and there has to be and we should have equipments to bring in that water source to extinguish that fire. It also recommends having fire extinguishers and fire exits on each level. Even having after all this, if people are not really aware of circumstances, then all of this is not going to help. Due to that reason, the fire department emphasizes various premises on conducting fire drills. They themselves create an event and use these equipments to extinguish a fire. So in their overall routine, they usually practice for such events, and they usually audit various facilities whether they are ready for such events. How does this help? Basically, when there is a practice, complex things and unknowns start getting known, simplicity comes into picture, and with simplicity we start building confidence and trust within the system. Predictability increases, and this is exactly what chaos engineering does for us. Chaos engineering, by definition, is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions which we observe in production. Let's try and understand these turbulent conditions by taking an example of a microservice. On a microservice, basically a particular microservice, when it starts, it has various routines it executes. When the startup time of a particular microservice is longer, when the startup time for a particular microservice is longer, it usually is very difficult to support incoming requests. You may have observed that on various instances, there are varied load which comes in, and if my startup time for my microservice is higher, usually I will not be able to cater those requests. When there is a burst which comes in, due to that burst, there is a load that we are putting on our dependent services, due to which they can gradually degrade. And the gradual degradation that we observe on those dependent services, which eventually degrade us. These are various turbulent situations that you may have observed in production. I will go one slide behind because we missed one important thing. We need to ask a very important question, whether we are ready for chaos in production. From that particular perspective, do we have ability to respond to failures? On a particular event, there are multiple stakeholders who are running the show. As an incident manager, I am responsible to keep all the stakeholders in place and deliver actions to them. From that particular perspective, does our every stakeholder understand their ownership? As an engineer, during the design phase itself, have I considered various resiliency aspects? Do I have identification, prevention, and restoration in place? As a NOC, we need to understand what is our reaction time. Are we better at it? Is the actions defined for every stakeholder, they are aware of it, and are they aware of the behavior of the system on which an event has occurred? All of this is possible and feasible if you have a well-established process. Chaos engineering exactly helps us building that process. It helps us building readiness for chaos incidents. It brings in awareness about the system behavior, and it improves our response time on the events. Now, let us understand various factors which contribute towards readiness of a particular system from the fault tolerance perspective. First, we need to identify whether we have data to figure out there is an event. Using this data, do we have alarms informing various stakeholders that there is an event? And do we have dashboards to pinpoint where the problem is? Prior to that, if we have considered various resiliency aspects under our design, we will not have to be in a situation to identify and restore things. If under our implementations we are using rate limiting, circuit breaking, automated failover, there will be less chances that we will have to fall back to risk mitigation. Suppose we are in an event, we have to make sure that we have rollback mechanisms in place. There are restoration scripts which are in place, and all the stakeholders do understand how to use those and restore the system faster. When it comes to a software development lifecycle, we have product managers, engineers, SREs contributing at various levels. Our product managers usually define the SLA. These are commitments that we make to our customers about the service availability and performance. To meet these SLAs, there should be goals which we have set, and these goals are defined by performance engineering, product, architects, and we have to implement and design to meet these goals. From the SRE's perspective, they cross-check whether we are ready to meet these goals, and they come up with various ways to indicate if there is a gap. From the SLA point of view, there are systems which can be 2.9 systems, and there are systems which can go up to 5.9. The investments that are involved under architectural, implementation, testing, and operational phases is directly proportional to the SLAs that we promise for our software. Now, let us understand what is maturity from the chaos engineering point of view. Like you see under the image, under the first image, there is a diver who is in direct contact with a shark, but has less gear with him. On the contrary, on a maturity level 4 image, you see that diver has been supported by a team and has ample amount of equipment to protect him. The same analogy applies to software development and chaos engineering. Softwares which have 2.9 SLA usually carry high risks, but the investments are lower. Whereas software which are 4.9 and 5.9 usually have low risks, but have very high investment. As an architect, we have to invest into proposing multi-region failure strategies, parallel architectures if one path goes down. And we also have to think upon blue-green and canary enablement. If suppose things go wrong after deployment, how can I restore it? So there is a considerable amount of investment one has to do, understanding the risks. All these investments is based upon the SLAs that we commit for. There are known solutions for each and every problem. We should try and factor in those solutions under our designs. It is always better to be proactive during the design phase itself to consider resiliency. It helps us saving in time and money both. From the architectural perspective, if we are aware about the dependencies and the data that we depend upon, it is better we replicate those and be isolated. it is important that we have service isolation in place in such scenarios. Whenever there is an incoming load or spikes coming in, do we have auto scaling in place so that I can handle that load? Is my startup time low on my microservices, or am I using serverless architecture so that I can handle a huge spike? From the deployment perspective, if I'm deploying a new artifact and to be ready if something goes wrong, do I have blue-green in place where I can fall back to the older version to reduce down or control the impact of various releases, new releases? Can I deploy to a limited set of customers by using canary release model? And ultimately, even after doing deployments, if there are things going wrong, can I identify those? Can I restore those in time? These are few of the things that as an architect we should consider in early phases. During the implementation phase itself, as a developer, if you are using Java, you should be aware that whether I'm using libraries like Resiliency 4J, Hystrix, which have basic implementations of circuit breakers, which needs to be used while I'm making external service calls, so that if my service degrades or if that service degrades, it does not degrade me. If there are incoming spikes beyond my capacity, do I have a capacity to rate limit and protect my own system and don't percolate that particular load to the underlying system to protect them? If the overall processing of my system is beyond expectations, do I have timeouts so that this does not clog the whole system? In all of these cases, if there are few things not working, do we have exponential backoff implemented under our code? And to identify all this, if things are going wrong, do I have telemetry in place? Do I have a health checks in place to identify when things are going wrong? And to be aware of all of these unknowns and behaviors, we need to practice mock drills under our operational phases. We need to practice our rollbacks if something is going wrong. To identify all the gaps under what we discussed, chaos engineering plays a very important role. And to pinpoint the exact point or gaps under our architecture, implementation, and operations, chaos engineering will help us there. Now let us identify various scenarios on a taking an example of a microservice, where to invest under chaos engineering. You can go to your startup routines, first request or subsequent request, look into various operations that you do. You might be establishing a connection or doing a migration during the startup using tools like Flyway, or you will be storing something on the underlying database after performing some computations. With these operations, you can experiment in various manners. You can exert a load onto your system beyond capacity and observe how it behaves. You can bring down the capacity of your system during this load and observe its reaction. You can introduce latencies on various operations that we discussed and observe how my system reacts to it. And on a contrary, or as a last stage, you can abruptly terminate services of the dependent system and see how your system behaves. With all of these experiments, you will observe that there are timeouts on the various requests that you are receiving. There are request denials because there are huge spikes coming in and I cannot support. There are alarms going around because latencies is getting introduced on various services. There is request denial from various dependent services. In all of these situations, as far as possible, my system is scaling up to support this load. If we observe all of these behaviors, we are doing good. If not, we should go and check our architectural and implementation considerations and figure out what are those gaps. While we went through various design implementation considerations, there are various stakeholders who have responsibility to showcase during chaos engineering or under the chaos engineering process that we practice. As a product defines SLAs. They help us in coming up with goals to meet those SLAs. As architects, we need to make sure that we consider resiliency as part of the design phase itself, which helps us meeting those SLAs. As engineering, so that we protect our instances, our systems at the first place. Are we using resiliency libraries like Hystrix, Resiliency 4J? As a SRE, do I have a understanding of various SLAs committed by us as an organization? Do we understand the goal, and do we have indicators indicating gaps under those SLAs committed? And as a NOC, if in case unfortunately we are on an event, do we have ability to respond to those failures? With this, I will hand it over to Mehul, where he can run us through the plan of implementation to implement chaos as a process under an organization. Over to you, Mehul. Thank you.
Thank you, Yuvraj, and hi, everyone. So in the second half of the presentation, we'll talk a bit about how chaos testing or engineering can be implemented as a process in software development lifecycle. We'll then talk about the roles and responsibilities that different individuals can play in broader terms, and how to create a kind of responsibility matrix as to what will be done by whom when you are creating chaos testing practice. We'll talk a little bit about tools and technologies that are available and how to choose the right tools and how to go about that. We'll then take an experiment, a sample experiment, and we'll try to see how the outcome of that experiment can help us, pointing into the direction of resiliency consideration that Yuvraj talked about. And yeah, so let's get started. So chaos in a multi-tenant application, generally, as Yuvraj mentioned, and we keep repeating this again and again, stability is one feature which is used by each and every user. I mean, there are multiple features you are developing. Some customer might be using one feature, some customer might be using other feature, but stability is something that's going to impact each and everyone. So chaos being one such practice which actually tries to strengthen the stability or resiliency of your system, it becomes important to implement that as a process. And here is a 6-step or a multi-phased approach to implement chaos as a process, in which the stage 1 is basically elementary, where you will basically try to understand, what chaos is all about, what chaos engineering is all about, what industry leaders are doing in this arena, what are the terms and terminologies that are used, what are the tools and technologies that are used, what kind of output they are getting, and creating what kind of output you are getting, and trying to retrofit in your application's nature. See, one thing you need to understand very well, that chaos as a practice you can understand from one organization doing it, but ultimately it's your application's knowledge and how that practice helps you is something that is going to make your chaos practice the best possible. The stage 2 is basically, now you know what chaos is and how it fits into the paradigm of your application. Stage 2 is basically understanding the tools and technologies that are available and trying to choose the right tool or set of tools that you would need to use for chaos, for your chaos practices. It is certain that if your application has certain level of complexity, which most modern system has, it's not possible to just rely on one tool, but you'll have to have a set of tools to use to do the right level of chaos testing. So basically, stage 2 is understanding the tools and technologies and creating your own arsenal of tools. Right? They can be custom scripts also, for that matter. Stage 3 is now you know the tools and technologies that you're going to use. Now you know what kind of chaos you want to do, but it's still a gray area. I mean, not a lot of people know about what chaos is, and there are apprehension. Why are we doing this kind of negative testing for that matter? So basically, stage 3 is doing some trying to grab some low-hanging fruits in terms of chaos. Maybe trying to do a simple chaos and see what happens, and which you always were curious about. Try to run that and see what happens, whether the expectation from that particular failure is met or not. Because if you find some early success there, you can project that and you can get the confidence of the stakeholders to implement that as a process. Once you have gained that kind of confidence, and you have prepared your pitch around what are the tools and technologies, the stage 4 is basically creating a process. So again, in today's world where most of the things are CI/CD, the features keep going into the production very frequently compared to what it used to be earlier. Stability is not something, or performance, or for that matter any non-functional aspect of application is not the requirement, not the responsibility of one particular individual. Every feature lead, every developer for that matter, they need to think about, I'm developing this feature, but how can I make sure that it meets the non-functional criteria that are set there, through testing, through design consideration, and all those things, right? So similarly, chaos is not going to be in such manner, in such kind of environment. Chaos can't be responsibility of one person. It has to be responsibility of everyone which is involved, that is involved in development, and hence creating a process to think about chaos at the stage of grooming an epic. When you are choosing the services or infra, at that phase itself, thinking about something related to chaos, and then creating some test cases around, seeing what kind of chaos you want to do, consulting around that, and doing those things are very essential. And hence there has to be an established process that every team can follow, just like there are processes in teams for performance testing for feature, or for that matter any non-functional testing. So non-functional testing, once the process is established, the next step is to tell people about the process and how to implement that, and make sure that guide them to implement that as a process, changing your documentation, and changing your acceptance criteria around that, keeping game days and things like that, where you keep a check if if some where you actually kind of simulate what's going to happen in production, exactly with involving all the stakeholders. So creating those process and socializing with everyone. With the multiple iteration of all these stages, ultimately your application would reach in a position in a position where you will have a much more better confidence in the resiliency of different aspect of resiliency of your application. And then the ultimate or ambitious, or the litmus test is to test your chaos in actual production, where it is actually supposed to work. So that's the stage 6, where you can go into the production. You can think of going into the production and doing your chaos in a controlled manner. Of course, it's not going to be a 1 day or 2 day practice. You have to be sure about the chaos that you want to do in production. It has to be tested multiple times. It has to be, the fixes have to be applied. And then even in production, when you go, maybe you will like to do some chaos in the deployment or the maintenance window first, and making people aware that see, this is working. We failed this, but still our service is working. And then eventually, if your process matures enough, you can say there'll be anytime chaos, and let's see how it works. So chaos is not only just about finding the issues and fixing them, and that's the main objective, but also making sure that people are aware what kind of responsibility they have if that kind of event that kind of event appears in production. And that can be actually done by repeated practice, right? So this is a phased approach that you can implement, that you can adapt. Now, based on the approach, you can see there is a lot of convincing that is required with the stakeholders. There is a lot of groundwork that you need to do in order to, and at the same time, there is a lot of communication that you need to do with each individual Scrum team. So to implement this, or to adapt this implementation process, we can have a three-layer team structure. We can make a little bit of alignment in our team, where at the heart of it would be a COE kind of team, which you can call chaos team. And the responsibility of that team is basically doing the initial is to do the initial groundwork, tools and technology evaluation, talking to architects, and talking to the stakeholders, the QA management of your quality leadership of your team, and things like that. Then comes this team is basically responsible for doing all the groundwork. The QA lead is basically then this team will at one end, it will talk to the leadership and tell them the value addition that this practice can bring. At the same time, this team can also talk to the POC of different teams, which are generally architect or QA lead, to help them implement this process in their individual day-to-day work. And ultimately, the Scrum team, which is going to adapt this practice, and do the testing, actually do the actual chaos testing, because they are close to feature, they are close to the infra they are using, they are working on they are working day in, day out on that. They know the feature that developing the best, right? So it's they would be the best person to judge whether it's working according to the expectation or not. Of course, they can consult the COE team for any feedback or guidance there, but ultimately the execution, the feature related chaos testing execution should remain with Scrum team. And on top of that, you can have a gating criteria, like doing every sprint, doing a like you do your cadence testing. You can create a chaos game day kind of thing where you test it, and if it is not passing certain chaos, you are raising it before letting it go into the other environment in pipeline. So based on this organizational structure alignment, I mean, this is actually one such alignment. You need to see what kind of organizational structure you have, and you can tweak and tune this alignment a little bit to suit your, suit your organization structure. And based on the alignment that you do, you can create a responsibility matrix where to implement the chaos, what is going to be, Yuvraj, if you can move to the next. Yeah, you can decide the responsibility of each and every individual, the ownership and kind of role it will be the person would be playing in order to implement a successful end-to-end chaos. So we talked about the process and how you can implement that as a practice in your application so far. Again, it's just this all are just for a reference, but it's not necessarily needed to be applied as it is. You can tweak and tune based on what is expected out of different roles in your organization, and create the best suitable RASI metrics for your organization. Now, we'll talk about a little bit about tools and technologies that we can use for chaos testing. And that is actually a very hot topic. You will keep seeing, Yuvraj, if you can move to the next one. You keep hearing, different tools that are available, and there is a plethora of tools, right? So selecting right tools at times becomes very, very challenging. So you should keep three things in your mind, right? What is your infra? What is your architecture? And what level of depth you want to go do chaos testing for? These three things will, decide the tools or the set of tools that you should be using. For example, if I give a comparison, there are multiple tools available. You can see some of the icons on the screen: Chaos Monkey for Spring Boot, Gremlin, Chaos Toolkit. If I give an example, yeah, you're right. Yeah, so these are some of the tools that you will hear. If you are, maybe AWS native, you can think of AWS fault injection simulator, AWS FIS. You can for a fair bit of injection, you can simply use Boto3 library of AWS, which talks to different services, and you can do a plethora of chaos using that free open source library. Gremlin is one such tool. Which is very famous or very, very talked about right now. So it all depends upon, as I said, the three things: the infra you are using. If you are using microservices and you have machines where you can install agents, and your major work happens on those kind of architecture, probably Gremlin might be a suitable tool because it needs to install the agent there. So things like that you need to decide. And then if other than that, again, the depth wise, you can see, then there is an entire simian army of Netflix which does wonder in terms of different kind of fault or failure you can inject in AWS different services as well as different regions, and different kind of janitor kind of activity and all those things. If you want to do certain things inside your microservices, and let's say, for example, they're Spring Boot based microservices, and you want to test, okay, what happens if my API 2 and 3 are failing constantly due to functional reason, right? I want to see if there is an impact. So those kind, or if there is a memory leak, whether I have handled that, through auto scaling or temporarily handle that somehow or not. So those kind of things, if you want to do at application level, you can use CM4SB for Spring Boot. You can write on your own tool also. You can use Chaos Lambda if you have Lambda and all those things. All those things in your things. At times, it is possible that you might need to write your own tools, right? Because not everything is tested for chaos at the moment. I mean, people keep building as and when they come to a particular thing and see there is nothing available. But it is possible that if you are using totally niche technology and nothing is available, you might need to write your own custom script, which can talk to your services and do the damage that you want to do. So again, it's very subjective there. But the three things that you need to keep in mind is, as I said, the infra, the architecture, the infra or / services that you are using, the architecture, and the depth you want to go to. Yeah. Now, once your chaos process starts becoming mature, what happens is if there are one or two persons doing chaos, they know what they are doing and they know how to what to look for, what not to look for. But once your process starts getting mature, it's essential that you create a proper way to articulate your use case, so that there is a uniformity across the chaos testing that is happening in your organization, as well as you also have reference when you are retesting something. So this is one such articulation template that you can use. The first segment in this is the configuration, and the second segment is basically the result. The configuration segment actually tells you the circumstances under which you are testing, right? So the first one is like which environment you are testing. I'm, for example, here saying for performance environment. What is the environment configuration? So I'm saying 3 container of MS1, just for example, right? And this is the configuration of MS1. You can get further details. What is the internal configuration of MS1? What kind of MS1 is that? An RDS, for example, here I'm using. And then I'm saying which service version it was tested on. And then what is the steady state load? Now, load becomes important because for most of the chaos, it's necessary to simulate the kind of load that it is going to expect in production in order to simulate it the right way. So this first 4 segments, 4 or 5 segments tells you about the environment, the condition under which I'm testing. Again, you can add more if you think, this should also be articulated. Then comes the result. So if you see, all the components and results are divided into 2 columns, expectation and actual behavior, right? Any deviation in actual behavior compared to expectation should lead you to mark your experiment as failed, because not necessarily if the expectation is not met, it's going to become an outage. That's not necessary, but at least it tells you that what you are expecting, your expectation about your application's resiliency is not right. So if not today, it might result in some kind of fault in future. So this is not just about outage. It's about whether you understand your resiliency, your application's resiliency in the right manner or not. So there are different components here. The first component is steady state hypothesis, which tells what normal looks like for my application, right? If nothing wrong is going on, what my application looks like. So for example, I'm saying if nothing wrong is going on, or this is how my application behaves. The response time is generally 90th percentile response time is 350 millisecond, and success rate is like 99.99. Then the second component is what I'm going to do in this experiment. So I'm saying here is termination of one third instances of MS1. So basically, I'm terminating one instance of my microservice. Then the tolerance threshold. Now you are doing something nasty with your application. So in most cases, you will expect some kind of impact on an application, right? Tolerance threshold tells what is the level of impact that you are okay with. So beyond that, if your application goes beyond that, that means it has failed. So here I'm saying I'm fine as long as the response time degrades till only 700 millisecond, and I'm fine as long as success rate is not below 99. So I'm fine to take that kind of hit because I know I'm doing some experiment. Then comes the blast radius. So blast radius is actually the area that you are expecting to be impacted by this experiment. So in this case, I'm saying I'm just touching MS1. So and MS1 doesn't have a dependency on anything else. So only MS1. And then rollback. Rollback is basically how the impact of that experiment is going to get taken away from the application. How does the impact of the experiment going to get to be taken away from the application? So in this case, I know that it is a container-based microservices, and there is a container orchestration in the backend, which takes care of making sure that right number of containers running. So I know that so my understanding is that rollback should be automatic, and then expected recovery period after the rollback. So once the experiment has been taken away, within how much time your experiment needs to be, you should come back to normal state. What is your expectation? Now you see all this expectation that you are setting, they are setting, it's not random. It has to be well thought. You first need to understand what your architecture is, how it behaves, right? And at times there would be some product consideration also to take into to think about. So for example, I told you how I came up with the rollback. I knew what happens in the backend. I knew my infra. That is why I know the rollback has to be automatic. I know that the blast radius has to be MS1. At least that is my understanding, because I know that MS1 is an totally independent service. It doesn't talk to anyone. So I don't see any reason why others should be impacted. And that is what we are kind of validating with this experiment. So all this expectation is something that you can set right only when you know what you are expecting out of your application product wise, as well as the architecturally. So that based on that, you will set an expectation, you will run the experiment, and you will see if you are meeting them. Then fair enough. If you are not meeting any of them, you will just mark that test as failed, and you will just tell the reason, that what expectation criteria was not met. In this case, I'm just, and again, this is just an example, this is not a real experiment. This thing I'm saying here, blast radius is more than expected. Maybe ms2 also got impacted, which I was not expecting. So I need to go to the design board again and see why ms2 got impacted, and do I need to maybe raise a defect to analyze that. So this way you can articulate your use case. And now we will talk about the actual experiment, one actual experiment. Again, it's an example experiment, and how it can help you, how it can point you towards the resiliency consideration that Yuvraj talked about. So let's take a simple example of Spring Boot based microservice. It's a simple microservice, containerized microservice, and the data source is DynamoDB. For those who don't know, DynamoDB is a data source, fully managed service, data service provided by AWS. Now, based on now factors that impact any this microservice, and for that matter, any microservice, there'll be threefold. First one is, and this is actually very generic, you can see what those three are. Performance engineer on the call might be aware of little slow, so that little slow, so something related to that. This is the transaction arrival rate, the number of requests that you are getting. You can call it TPS, HPS, RPS, whatever. The kind of infra that you have, the kind of configuration that you have given to your microservice, be it heap size, number of threads, and all those things, and the processing time of each and every request. So we know that service health would be impacted by change of all these things. In this in any of these three factors. In this experiment, we'll try to see what kind of hindrance in processing time my microservice can take or can handle. And for that, I'm taking use case as communication lag between microservice and DynamoDB. Now, it's logical that, if there is a lag between DynamoDB and microservice compared to the normal condition, your overall processing time will get impacted, which will impact your performance, and eventually it might impact your service health. So this test will do, we can take some benchmarking load for this microservice, like what normal works, and we can create tolerance threshold criteria around that. So here I'm saying tolerance threshold criteria is like, generally for the load, the benchmarking load that I'm running, the 90th percentile response time is 350 or 400 milliseconds for this microservices, but I am fine as long as it remains below 2 seconds. The resource utilization, or to be precise, CPU utilization, for example, it is generally 45 to 50%, but I am fine as long as it goes 80%. And because I'm trying to test the limit of my application. And the third tolerance threshold criteria is my service health check should not fail, which means my service should not totally go kaput. It should not totally go down. So these are the three tolerance threshold that I have set. The base load I know, and I know how normal looks like in that. Now I'm starting the experiment. So if you see the experiment, we can create if there is no delay, the steady state or the normal condition, the response time is 350 milliseconds, as I said earlier. The container CPU utilization is around 45%, as I said earlier, and the service is healthy. I start with 30 millisecond delay in the communication. I see the response time jumps to 400 milliseconds. Fair enough. Then I go to 100 millisecond. I see the response time further jumps. Then I go to 200 millisecond, and I see that response time is not now linear with the delay introduced. The response time is increasing now a little bit more than what the delay is introduced. I go for 300 millisecond delay, and I see that one of the criteria is already getting breached. That is, the response time is now 2.1 seconds. So there is an exponential jump in the response time. But the other criteria are still met. And at the 400 millisecond, obviously the logical thing is the response time will further go through the roof, and the service restarted. So based on that, there are two conclusions that we made here. First one is, for the actual experiment, we know that a delay of more than 200 milliseconds in the communication between microservice and the DynamoDB is not something that I can tolerate for the kind of load that I'm testing, or for the nature of application that I have. The second important observation is that, after a certain point, the response time increase is not linear with the delay introduced. And that is actually logical if you think, because after a certain point in time, it's not that the delay that is just getting added in your processing time. There is a fight for resource also that is happening, right? We can take an example of a gym. Let's assume there is a treadmill in a gym, and on an average, there is one person comes to the gym every hour, and he does exercise for 30 minutes. So everything would be hunky-dory, and as long as that person is taking till 60 minutes, because there will be new person after 60 minutes, right? So till 60 minutes, one person's delay would not be impacting other person's time at the gym, right? But once the delay starts becoming, let's say, 90 minutes, so what will happen for the second person? He will have to wait 30 minutes for, first of all, to get the resource or get the treadmill, and then he will take 90 minutes. So total he'll take 120 minutes. The third person, the third person who came, he will have to wait 30 plus 60 minutes. That means total 90 minutes, and then 90 minutes of his exercise. So after that, after a certain point in time, it's not there is a ripple effect of resource crunch, and that is what is happening precisely here. Coming back to experiment, so based on this, we know that beyond 200 millisecond, it's all problematic, and we don't know. It's not going to impact just that particular API. It can impact overall health of the microservice. And then you need to say, okay, DynamoDB, does it really take 200 milliseconds? So if you see the DynamoDB's claim, they call, for most of their use cases, it's a 2-digit millisecond response time for them. So I'm saying, anyways, DynamoDB is fast enough. So and I know that a delay of more than 200 milliseconds is going to impact me. So I'm saying, let's cut the communication with DynamoDB if the execution time is more than 200 milliseconds. So the recommendation can be like, if you're using AWS DynamoDB client, which you most probably would be using in your Spring Boot application, you can say, okay, fair enough, this is the number of connection, blah blah blah, and everything. But if any client is not returning in 200 milliseconds, just drop that, because it's not impacting only that; it's going to impact the entire service health. So yeah. So this is one recommendation, and then you can test it and see how it works. You will see your service will not degrade overall. You'll see failure. This is called fail fast. I mean, if in case of degradation, it's better to fail fast than to optimistically keep waiting for resource to respond and impacting multiple other users also. So we are basically implementing fail fast there. So based on this experiment, you can see it gives us multiple pointers. We performed the chaos experiment, and we got the benchmarking, a certain kind of benchmarking. One benchmarking is that a delay of more than 200 milliseconds is not something tolerable. The second benchmarking of overall processing processing degradation of 2 seconds is something that is not tolerable. So this can be actually become your input to a lot of development and architectural consideration. For example, timeouts, as we said, we can set client execution timeout. According to this experiment, it was 200 milliseconds. Rate limiting, if you have a rate limiting based on the thread processing time, right? How much time? I mean, if you have that kind of rate limiting, you have a pointer about what should be your tolerance there. Basically, you can say if your current execution threads are taking more than 2 seconds, if your current servlet calls are taking more than 2 seconds, probably reject other requests, because you are anyways degrading. Circuit breaker, again, if you have a parallel path for this DynamoDB communication, you know that if 200 milliseconds is something, that's the limit. So you can configure a circuit breaker to go away from DynamoDB and go to second path if you at all have that. So you have pointers about circuit breaker as well. Observability, you know that you are using DynamoDB, and in production, it's good to have certain monitors around your DynamoDB performance. So you might think of including certain matrices or certain logging around how much time on an average you are taking on the DynamoDB operation, which will further help you in the debugging in future production. So this was just a very simple example, and just to give an idea how to correlate. Again, it's not necessarily that this will apply to each and everyone as it is. You need to understand, as I said, you need to understand what your application does and create your chaos around that. So it can be, if your application has auto scaling, you can create maybe chaos around seeing whether your auto scalings are actually getting triggered at the right point in time. If you have maybe health check timeouts, you can create your chaos to fail them and see whether you are too lenient or too aggressive with your health check for the nature of your application. If you already have implemented circuit breakers based on certain understanding, you can verify them as well, that whether they are actually up to the mark or not. And once your process starts maturing, maybe if you know that all this low level design level things are taken care of, not design but development level, mostly development level things are taken care of, am I resilient enough to handle my cloud provider's failure, right? So maybe you can think of using simian armies to or chaos kong or all those things to simulate those kind of failures, or where you take the entire availability zone or entire region out of your equation and see how it works. So it all again depends. You need to understand your infra, you need to understand your architecture, you need to understand the expectation out of that and design your chaos accordingly, and try to see how better how optimally you can use the outcome of that chaos for different consideration, not only a few consideration. With this, I will hand it over back to Yuvraj for concluding the presentation.
Thank you, Mehul, for helping us go through various stages of chaos engineering and establishing chaos engineering and practice at an organization level. This also thank you for going through the experiment and helping us understand how we have to consider chaos engineering principles under our articulation. It also helped us connect the dots and understand how resiliency and chaos engineering goes hand in hand as a test and as a solution. With this, we have added abilities to various stakeholders because as a practice, one of the practice under chaos engineering, we perform mock drills. This makes all the stakeholders aware of various faults which can get injected if systems are degrading or if things are failing. As we continuously practice, we start gathering experience, and with experience, we continuously build confidence on our system. All of this helps us meet expectations of our stakeholders, as well as it helps meet expectations of our customer. This adds to the ability to react in a right manner on our various systems. Now let us recap few things. From the first, we try and live to the expectation uptime is there. We do understand the radius of impact. The reason because as NICE works for various domains and has a fleet of cloud native suites which serve healthcare, emergency services, and banking and finance domains. Due to that reason, we proactively during our implementation and design phase itself, we consider resiliency as a major factor. Just in case there is something new which we observe and there is an event, we learn from those events and we inculcate those as new experiments under our chaos engineering factories. With this, I will conclude. I hope sharing this experience of ours has helped you gather thoughts around chaos engineering. Chaos engineering is not something that you just need to think that it is done in production. You can follow a process, you can have phases in it, and you are the one who can finally decide which stage I need to go to and which stage I will stop upon. Thank you. Over to you, Aishwarya.
Thank you, Raj and Mehul. We definitely have a lot of questions. And for the ones who are asking for the presentation and recording in the chat box, please drop us a note to events@zinnov.com. We'll keep you posted on the same. Yuvraj and Mehul, I have to tell you, our audience have clearly enjoyed today's session and have fantastic set of questions awaiting for your inputs. Without any further delay, I think we'll get started on that. The very first question is regarding, do you have any automotive software use cases with respect to chaos handling?
We don't have as such exact use case for automotive industry, but as I said, right, it actually, the domain expert would be someone who can give you what kind of chaos you can do in this. But I think the example that I gave, you can take some hint from that and create your own domain specific use case there.
Absolutely. Yeah. Thank you for that. So the next question is regarding, can you brief us with an example by taking entire architecture for the different maturity levels?
Yes, definitely. I will bound myself because there are few informations I may not disclose on this forum. But let's take an example of a very core service that everybody requires. Login. If a person is not able to log into a system, nothing is possible, right? No services can be delivered. from that particular perspective, we need to be sure what is the SLA for your login. If I have a 2.9 SLA, it means that my system can be down for 42 minutes in a month. It's a huge time, right? 42 minutes downtime is a huge time. And that may not be acceptable for mission critical domains like contact center. And due to that reason, our authentication service exhibits a behavior of finite. There are various architectural considerations we usually make from the resiliency perspective. We try and cut down as much dependency as we can on external artifacts by replicating the data that we need. We have parallel data sources. Just because if something goes wrong, I can circuit break and fall back to my parallel path. Having said so, like we always say, if things go wrong, if there are few things which can go wrong, they will go wrong. If they go wrong in one region, we usually make sure there is another region where the same service is up, the data is available, and we can authenticate people in another region. This is a very good example of resiliency, SLAs, of finite SLAs, which usually defines your maturity level. It is we who need to understand what is our support ability, how much we want to invest, because finance doesn't come cheap. There are many architectural considerations and infrastructure considerations you have to make to reach a finite level.
Got it.
I hope that answers.
I hope, yes. The next question is regarding, will chaos engineering be helpful in all-time chaos-full apps such as downstream app connected to NYSE or a high volatile constant moving data linked app? What are your thoughts on that?
Yeah, so precisely something similar we saw in the application, in the example, right? It was not as volatile as you might think NYSE to be, but ultimately the idea of chaos is taking one service at a time and seeing how much dependent it is on the downstream system, and how can we disconnect, and how can we make sure that if the downstream is not responding the way it is intended to, how can we not be impacted or be less impacted, right? Again, now coming to the downstream, if you know that your downstream is possibly, so first thing is securing yourself. For that, you can put right timeout or exponential backoff to not go to that particular downstream after certain time, and that is what this kind of chaos of dependency related chaos would tell you. The second would be, once you know that if your downstream has an SLA which is lower than what you are expected to deliver, the idea is basically now you know that let's say you are 5.9, your microservice is 5.9, but NYSE you are taking example, it is 2.9, right? So I know that I can't totally rely on this thing. Then my implementation should take care of maybe replicating some of the NYSE or the whatever downstream it is at certain place, and keeping it refresh, and keep refreshing it at certain frequency, and rely on that data source or that particular thing in case the NYSE again I'll not name the NYSE, but since it is mentioned, so it is coming back again. In case the downstream is not responding. So first step is making yourself sure and sensing that downstream is not available and there is something wrong going. And second is, if it is too much and if it is hampering your SLAs, also probably talking to the downstream if it is under your control, or probably replicating, or basically what we call is parallel path of execution in that case. So that is precisely what this experiment was about, right? If in our example, if DynamoDB goes down, if it is going too frequently, I'll probably say I am okay, but there'll be a lot of failures because DynamoDB is not responding. So what should we do? We should have probably some other data source we can temporarily use or something like that, right?
Got it. Got it.
Hope I answered this question.
Yeah. I will like to add my 2 cents from the architecture perspective. It is really important for us to understand what kind of architecture we are using. Are we a strongly consistent architecture, or are we based upon an eventual consistency architecture? The data which is flowing down to our applications, what is the real-time definition of that data? Many decisions are based on this. And you may have to make those right decisions based on your use cases. Like Mehul mentioned, based on the underlying data store and its SLA, even we are impacted. If we want higher SLAs, we have to lay down parallel paths. If that underlying data source is down and I cannot save data there, probably I will have to save it somewhere else, and I will require a job. We will require a job which will move that data from the temporary data source to the original data source. With all this, our SLA keeps on getting better and better, and that's the exact reason why usually I emphasize that architecture for a particular system in its lifetime evolves to reach a steady state.
Got it. Got it. Thank you so much, Yuvraj and Mehul, for your answer. So the next question is regarding, do you have any checklist or best practices for the stage 3, which might be different for a production system compared to the new system, which is yet to go live? Mehul, you are speaking.
Sorry, yeah. So actually, that's a very good question, and we keep getting that from the team. How to go about, basically what person here is asking is how to decide what kind of chaos I need to do if it is a new system, basically, right? So it's very simple. First of all, try to understand what your infra is all about. If it is a container-based microservice, for example, right? What is the data layer you're using? The first and simple thing is just shutting that down under the load and see what is happening. That's very basic, that this thing. Second thing is, terminating the dependency and see what's happening, right? And then once you start understanding more and more, you can go from there. Then you can talk about, going for the latency between yours and dependency, things like that. I mean, your infra and the dependencies or the data source that it is using. You can further then go down once you start understanding the nitty-gritty of the things that you have used internally. For example, let's say if you are using some kind of pooling, right? Connection pooling, let's say C3P0, right? What if my all connections are busy in there, and what if they are not released? Or what if my database is not releasing, queries are very slow? What kind of, fallback or exponential timeout I have put on my C3P0. So once you start understanding more about your application and the components that are used, that then it becomes then you will come up with more use cases. It is pretty similar to functional testing. You try to understand what this functionality is about. Okay, admin can do this, he can create, he can not create, and he can list. Then you think about, okay, what if he's trying to do delete, can he do this? So it's pretty similar to that, except it is not on the functional level, it is on the infra and architectural level. So the initial stage would be just simply terminating that thing and trying to see, and of course in the lower environment, and trying to see what is happening, and try to correlate that with the expectation, whether it is expected, or try to understand that, because that will give you a lot of question. Okay, after terminating it took 10 minutes, but the health check is, let's say, 2 minutes. Why it is taking 10 minutes? Let me tweak the little bit of health check and see if it is impacting or not. So that's precisely how you start with the chaos testing. Hope I answered that question, Sujesh.
I hope, for sure. So there's a follow-up questions to that, right? Regarding the stages that you were talking about. Do you think there should be a feedback loop from stage 6 to stage 3 for process optimization? What are your thoughts on that?
I think it's not only for one stage; it's for every stage. It's just that it is not mentioned in the group in the PPT because it will make it very cluttered. But every stage has a feedback for every subsequent stage. So, for example, socializing. In socializing, if I get to know certain limitations of some teams to implement that or certain different way, maybe that will become my process creations. Will become an input to my process creation itself. So it's not only stage 6 to stage 3, but basically every subsequent stage would be a feedback loop to any of the below stage which is already covered. So at the time of, for example, again, socializing, if I find that one team is using certain thing which is not covered, maybe I need to go back to the stage 2 and see if there are some more tools that I need to acquire or maybe create around that. So it's actually not only to answer the question, not only from stage 6 to stage 3, stage n to any stage which is less than n-1, less than or equal to n-1, basically.
Okay, got it. Thanks for that. So also there is a statement saying product manager should be involved in the organization structure and RACI. They are the owners of the product and would establish the priority order for the chaos parameters. What are your thoughts on that?
Oh yeah, it's a very good point, guys. In fact, the RACI matrix that we have has been established from the R&D perspective as the initiation point of any commitments that we make inside and outside. are based on the SLAs, where product plays a major role. They also play a major role on defining goal to meet those SLAs, right? From that particular perspective, yes, product plays a very important role. At the end of the day, we can define, as engineering, we can define the severity of the things that we observe after conducting an experiment. The priority is been decided by the product to invest into it. A good feedback, guys.
Got it. Mehul, do you want to add something to it, or can we get started with the next question?
You're on mute.
I think we can get started. I think Yuvraj covered it. And in fact, it is part of this, the Scrum team. I mean, when we say Scrum team, we might have not put that there, but SLA and all those things anyways come from product. So they are, I mean, if it is not meeting, probably it's dev team's responsibility to make sure that we are meeting to them. And that way, anyways, product is part of that. So I think, Yuvraj covered it.
Got it. So chaos is one of the major areas in SRE. Could you please tell us where does SRE team fit in the organization structure, and what will be the responsibilities of SRE team?
Sure. I think I'll take this up. I'll take this up, Yuvraj, and maybe you can add it. SRE is definitely, and I actually keep SREs, performance engineers, and DevOps they into kind of same bracket, because again, it might sound controversial, but they kind of do. The aim of their role is pretty much aligned with each other, basically. So SREs are basically in the organizational structure that I talked about. They can be definitely in the central chaos team, some people from the SRE, because those are the people who ideally understand the application, not from one module's perspective, but entire application's point of view, as well as the infra and other things. So they are the people who should be at the core of that. At the same time, they are anyways part of the actual issue that happens in product. So that I don't need to mention, they are already there. There is one more thing which I talked about, which is game day, right? Game day is basically nothing but deciding a day where you are failing the system, integrated system, and everyone is playing the role of everyone is playing the role that they are supposed to. So that's a place where SREs, I think, would be very critical, because they know what to fail, what to look for, and they have been doing this and in and out, and they have been seeing this in and out in production. So they would be the right people to kind of sometimes simulate certain of the scenarios that are that happens in production. And if they have done that in isolation, maybe giving recommendation also. So I actually keep in this, at least as far as chaos is concerned, I keep PE or performance engineer or the non-functional architect and SRE in the same bracket. They have absolutely same responsibility in terms of this thing, in implementing this chaos as a process.
Okay.
Yeah, Yuvraj, if you want
to. I will. Yes. I will add a couple of things there. Like we all know, right? We have functionalities that we deliver, and we assert those functionalities under our testing phases. May it be in an automated manner, may it be in a manual manner. On the similar lines, whatever promises that we make for our SLAs, SREs are the one who certify it, whether we live up to that expectation in production. So go and monitor the error rates or the success rates in production, come up with a way and formulas to have an indicator which will highlight gaps in between our commitments and the actual observation 3959 49 in production.
Got it. Thank you, Raj. And Mehul, I think Swapnil, I hope it answers your question. There's another question from Swapnil is regarding, is there any related tool in OCI or GCP similar to in AWS SSM Chaos Runner?
Sorry, at least I am not aware of, Mehul.
Even I am not aware, but I'm pretty sure, these are very famous cloud platform. They would be definitely something. We know about this thing because it's about, what you what you have worked upon and things like that, right? So it's from the experience. But as I said, it's all about exploration. At the moment, for the platform specific, we don't know. But it's my hunch that, being GCP, especially being a very famous cloud platform, I don't see any reason why I would be surprised if there would be nothing, at least for the
I
basic.
agree. I agree.
And
agree.
as I said, right, reliance or tool, if it is available, yeah, well and good. It saves a lot of effort. But at times, eventually you will reach in a position, no matter what you use, you might want to do some kind of chaos which nobody is doing. And for that, you might need to, invest some time there as well. So frankly speaking, the tools we are not aware, but my hunch is definitely GCP. There has to be some or the other tools covering some aspect of chaos.
Yeah.
Got
Yeah.
it. Got it.
It might it might not be that you are able to cover the whole fleet even if few things are not available, but definitely like we have chaos for Spring Boot, and we can write our own mechanisms to introduce latencies and failures. It will definitely be possible to perform chaos engineering. It is in fact even possible to perform chaos engineering on monolith and cluster oriented applications. Even if Netflix initiated chaos engineering in 2011 while they were moving from data centers to cloud, chaos engineering has evolved. People have made their own thoughts, have came up with their own processes where using various tools, it can be even performed on legacy applications.
One more thing is chaos should not be, tool is very good. There are tools which are very well advanced. They saves you a lot of effort. But the idea is, understand your application. At times, you might not even need to use for certain tools for initial level of chaos. There is a case study of Hotstar where they are telling that, for their chaos, they are simply going into the environment and changing it from the console. So ultimately, the idea is not to, obviously, it's the ideal stage to have that automated and everything. But the idea is to, as fast as possible, introduce that and see whether you are ready for that when it happens, basically. So if you can just go manually and try to terminate some instances, right? That is definitely possible in any environment, right? Monolith or whatever cloud. So idea is to get started and then in parallel, keep searching for tools and then maybe develop our own tool. We are also developing certain tools for certain cases where we know that nothing as of now available that meets what we want to do, basically.
Okay. Thank you so much for that. Is it possible to use service mesh like Istio, ISTIO? Hope I'm pronouncing that right, for chaos engineering?
Yes, for services which communicate with each other overall. At the end of the day, there is a dependency in between those services. And yes, chaos engineering can be applied there.
Is there a tool or a way on which, how can we automate chaos testing for microservices?
So yeah, I'll take again. I think we covered a little bit of Spring Boot based microservices. There is again in microservice, what you want to do. Do you want to go inside? And maybe I think this question might have come before we took the example, but I'll still answer. If you want to go inside the microservice, let's say we know that we have Spring Boot based microservices in certain places. We wanted to do certain chaos inside, as I said, API failing, leaking memory, functional failure of API, certain APIs failure, service level failure or controller level failure and things like that. So for one such microservice, I can tell you that there is already an open source tool that I talked about. If your microservice is based on some Python, again, you can search, you will find something. If by microservice you mean the container, the Docker, and if you want to do that, probably then you can use any standard tool like, in fact, if you can just go to the C group of, for those who are aware of the container, how container works, there you get a C group and namespace assigned. You can go to the C group and you can just run a stress-ng process to saturate CPU and all those things. So it all depends within microservice, what is your aim? As I said, if it is inside going to microservice, there are tools for Spring Boot. I'm pretty sure there are for Python as well. But if it is Docker, standard Docker, you can just simply see how Docker works. Just go to the C group, install the stress-ng, that's a utility on Linux, and just try to hog the CPU or memory out of that particular Docker's C group. So yeah, these are the two ways that you can do for microservice. I hope I answered the question, but if you have specific platform microservice, then you can put the question and we can think for that as well.
Correct, absolutely. So if you have a follow-up question to the one that you've already posted, please keep us posted over the chat box. We'll try to answer the question. Just a heads up to the rest of the attendees as well. We have quite a bit of questions that have come our way. We'll try to as much as possible, answer as much as possible in the next 8 to 9 minutes that we have. Rest of the questions, we'll try to answer it offline and send it over to you. To the next questions, how do you think we can conclude on the tolerance threshold?
Yeah, good question. Thresholds are something which needs to be found, and those can be effectively found if you are benchmarking your services before they are deployed. If you know your limits, then definitely you will be able to find the tolerance threshold. For that particular perspective, before you get into the solutioning part of chaos engineering, one needs to have a good established performance engineering process. With a well-established performance engineering process, you will know the benchmarks for your various services. You will know the limits for a particular instance, if it is a microservice, as we have been discussing more about microservices. Once that limit is understood, just the way Mehul presented it under his experiment, you can establish timeouts when things go beyond our expectation to protect ourselves.
Got it. Thank you for that, Yuvraj. The next question is regarding, are we expecting a downtime during the expected recovery period and rollback? What are your two cents on that?
So again, it's a generic. I'll answer. It's a generic this thing, right? I mean, to expect the downtime, there are two things. One is the business aspect of it, and the one is the technical aspect of it, right? Now, I know that when I'm architecturally, when I'm running a microservice, if the container goes up, right? Based on my benchmarking, I know that ECS senses it in two or maybe two minutes or something, right? So it senses it in 2 minutes, and then it will spin up, and then JVM will come up and things like that. So downtime is very subjective. You need to understand what your application is about and how much downtime is expected technically. And if the technically what is expected is not meeting your business criteria, that means the architecture that you are putting is not something that is suitable for the kind of requirement you have. For example, let's say if you have a 5-second downtime, maximum 5-second downtime allowed. Obviously, a container itself spin up for any. I mean, I'm taking just an example, but any normal container will take more than 5 seconds. So you are not going to get response immediately. So you know that that's not the right way. We need to probably, if we can't rely on one this, we need to probably have certain other, maybe Lambda or maybe running multiple containers, things like that, and maybe sense it early, things like that. So downtime is basically, it's very subjective. It's actually dependent upon two things: what architecture you're using, what it does when it goes down, right, and how effectively it does, and at the same time, what is your business need? Whether the architecture meet with your business need is not something that you test with chaos, basically.
Yeah, the downtime. Yeah, the very specifically considering downtime, right? It depends upon the maturity level that a particular service exhibits. If it's a finite service, it is the downtime which is allowed is 2 seconds per month. In a manual, it is not possible to have downtime and restorations to be done manually. So one has to invest into programmatic failovers, regional failovers. If we are using AWS, you may have to go to global accelerators and failover to a different region under your architecture. So restoration is also restoration invested into rollback, manual or automatic, is also based on the SLAs that we commit for. For 2 nines, we can have manual restoration processes. For 5 nines, we may not live with any manual processes. In case we enter into those situations, further announcements may have to be made for such services.
Okay, got it. Also, do you think we need to revise the benchmarking to amount or a number of customers you're serving time to time? For example, the holiday season, the load is very high. So what do you think we have to do at that point in time?
It's a good question. First thing, we need to understand architecturally, are we vertically scalable or horizontally scalable? if our architectures are right and we are horizontally scalable, whenever spikes come in, whether we are microservice oriented or serverless, from the serverless perspective, you may be able to handle those spikes because they scale up. But if you're a microservice oriented system, we need to be very careful about our startup times. As we use Spring Boot, your startup time may vary from as optimal as 20 seconds to as bad as 5 minutes. So from the during the day, during the peak hours, during events, when you are starting receiving more requests, will my system be able to scale out, right, to meet those requests? From that particular perspective, you have to make your technology choices first of all. Once the technology choices have been made, you can make it more effective by pre-scheduling or upscaling your infrastructure prior to the event if it is known. If it is an unpredictable event, definitely your auto scaling is the only thing which will safeguard you and your architectural considerations during your design phases for unpredictable events.
So the next few questions are more like a statement, myths and other things. So I'm trying to combine those questions, Yuvraj and Mehul. So one of them have talked about how chaos engineering is something that you do when your data center is down. The other person has said that can we assume that chaos engineering is an extension or an advanced version of failover execution and analysis? So do you think these are the general myths that you face, or there is any truth associated to it?
Very complicated question. I am still analyzing.
You want me to repeat it? I can definitely do that.
Yeah, please. Yeah.
Okay, so I'm just trying to combine two of the questions. One person has talked about, is chaos engineering something that you do when your data center is down? The other one talks about, is chaos engineering is an extension or an advanced version of the failover execution and analysis? Are these myths, or there's some truth associated with it? Was the question?
Yeah. First thing, I feel it is a myth that chaos engineering can only be practiced in production. Every stage that when we have inculcated chaos engineering as a practice, from the release perspective, you will be able to gain a level of confidence. The level of confidence may vary. If you are doing a chaos engineering in production, the level of confidence definitely will be high. If my data centers are down, right, that is disaster recovery, by the way. There is a thin line in between disaster recovery and chaos engineering. Chaos engineering is moreover to figure out the behavior of your applications when your dependent services are going down or latencies are getting introduced. Your expectations are not met in those situations by your dependent services. Whereas disaster recovery is something, by the way, disaster recovery is governed by a BSI standard also. There is a standardization which came from disaster recovery perspective in 2008. From that particular perspective, it moreover is from whether I can move my operations from one data center to another and how much time it will take. If suppose there is an earthquake where my data center is, it goes down, and what time will it require for me to shift all the operations from that data center to another data center? So it is the extreme end. At least chaos engineering is to a greater extent to understand the behavior of our software.
And I like to add two things there. It's simple, right? General disaster recovery kind of testing. It's basically to check your run book about once the disaster has happened, right? Whether you are able to move it to not. So it's like validating your hypothesis in case of disaster happening. Chaos is not about that. I mean, I would say disaster recovery can now become a part of chaos engineering. Chaos is not about only whether you are able to roll back or restore your system, but it also, if there are right preventive mechanism in place to avoid that altogether. So that's one thing. And and you will see that when disaster recovery earlier was talked, it was mostly infra people or operational people, they get involved. While chaos is something, it's not only because that was more about, okay, what if this region goes down, this service go down, or this node goes down, or this data center goes down. Here it is more about, have I taken care of those kind of things inside my code, inside my architectural design and all those things. So it's a kind of superset of, in a way you can say it covers that definitely, right, in much better way. But also it's more about, whether your application has the capability to sense that, or to maybe overcome that on its own. That's what the focus is. That's one of the added thing that chaos brings in compared to normal failover, FEMA, and FEM and those kind of testing basically.
Got
So
it.
it's not infra specific, and it's not only what after that, what after that.
Yeah, we
Got it.
tried to answer the first part. I hope we also answered the second part.
Yes, I hope for sure. Definitely, I can get it. So, I think we'll have one last question, Yuvraj and Mehul. And I have to tell you, there's another 10 to 12 odd questions that audience have been pouring in while you're answering the other questions, right? To the ones who are asking us for the questions, just wanted to call out here. We'll try to get them answered offline based on Yuvraj's and Mehul's availability, and we'll get back to you on that. So we'll have one last question answered from your end, Yuvraj and Mehul. Which are the tools are being used for the CX1 fault injection? Can you give our 2 cents around it?
So again, we can't explicitly tell the tools and all those things. I can tell the standard tools, and I probably have put them, and they are not copyright of us. So it's a standard tools that you saw in the screen, right? Gremlin is there. It's a very, very good tool if you have microservices, and basically if you have VM, and if you want to do, it gives you a way to automate your experiment, run at a scheduled time, trigger it from your pipeline and things like that. I think I'm trying to answer multiple questions in that, because I see some pipeline related question. So Gremlin is one such tool, but again, it doesn't cover a whole lot of experiment. If you don't have access to the service, like most of the cloud services nowadays manage, Gremlin would not be helpful. So you need to see, again, I might be repeating myself for maybe multiple times. You need to see what your infra is and what suits. One example I have given: if you are on AWS SSM, and you are using EC2 machines, you can go for either AWS SSM Chaos, and it's an open source library. You can go for Gremlin if your budget permits. So this is one thing. Lambda, if you are using, you can explore your own, you can write some decorators on top of your Python code to, and control it with some parameters or things like that. So these are the different tools that you can have. You can create on your own custom tool around the infra that you're using. And that is something that we can't disclose a lot about, like how we do that. But it's pretty simple to, gauge what we do, what we are using, how we can introduce chaos. Do we need to write a Python script? Do we need to write a shell script? Or can we use something already available? So, but I still try to answer to the best of my capability without exposing.
Absolutely. Yeah. Yes, I think, Michael, as you said, that you have answered a couple of other questions as well, which is almost on a similar line. Yuvraj, would you like to add something to that?
No, in fact, Mehul covered almost everything. But I can see a very interesting question, and definitely I will like to answer that, because that sets
Please
the
go
context. The question says, what is your recommendation on doing chaos in scale down environment? What are the best practices to follow? I will recommend that you do chaos engineering on a scale down version. In fact, it can be done at a particular instance level also. We know a fact that, right, frugality drives innovation. The less the resources you are able to support your business and have business continuity, do go to that level and do chaos engineering. Nothing stops us from doing better. What are the best practices? The things that Mehul covered. We need to benchmark our services. We need to know the limits of our services, and from the performance testings perspective, while we do it, when we exit load, do we have ability to scale up and scale down when needed? So we should follow industry best practices, 12-factor app during our implementations and the designing phase, which will help us be ready for any chaotic event that comes on a modern system.
Got it. Thank you so much for picking up that question, Yuvraj. I'm sure it answered the question. So with that, that's it we have for you today. Thank you so much. It was an absolute pleasure to host you both. And to the ones who joined us today, hope you found today's session insightful. Thank you once again. Take care and stay safe. See you soon in our next G.A.P webinar.